Welcome to the channel Tribe. This episode is a part of our webinar series TTTribeCast. In this episode, we are having Ravi Kiran talking on the topic significance of DevOps mindset on QA roles.
Hi guys. I hope I'm audible to everyone. So first of all, thank you for inviting me to present in this test types for Mumbai, and it's a real good opportunity to kind of present the skills of DevOps and introducing the concepts of DevOps into the testing practices. If there is any issue with my audio, or if you guys have any other questions, you can kind of immediately pop in or raise a question, and Mahesh can kind of pass on those questions to me. Is that good, Mahesh? Am I audible?
Yes, we are good, and we are live on the Facebook as well.
All right, sure. So guys, just to kind of start with the session for today, I am kind of going to give a very small introduction of myself and how did I evolve into the roles of DevOps from a manual and automation QA, and what all aspects of testing did I do, and slowly or eventually get into this DevOps enthusiasm, or the proactive working towards the development and operations working culture. So to start with, a very basic introduction of myself, I'm Ravi. I've been working in a variety of companies, I would say, startups and kind of product-based companies, service-based companies, and currently working with a research company. So this kind of an escalation has actually started with my first company in Mumbai, which is Zycus, and I was working there as a manual testing engineer. And slowly I was also interested in a few other areas like performance and security testing, and I've been working with people like Mahesh was one of my seniors there, and I was working along with them as well. So it was a very good opportunity to start with as a manual testing engineer, and you have that mentality of learning things and breaking things, so that if you want to break some things, you have to understand what it is. So is the case with the code or anything, right? So that is the same kind of a mentality that I had, and I used to learn quite a lot in terms of breaking the application from the product perspective, from the functionality perspective, and whether the code is actually working fine that way or not. And in this process, I understood that it is very important for a manual testing engineer or an automation testing engineer to have a very good understanding of the code, as well as to have a good rapport with your development engineers, or even with your product management team. So any successful team is only built on top of good communications, and you should not be building silos, right? So DevOps culture basically kind of puts forward that same thing, that start interacting as much as possible in order to kind of breaking the silos between individual teams. Don't say that is the development's responsibility only, because you have to also understand what exactly is something that they are trying to do. And if there is something that is needed from your side, say for example they want to introduce the test-driven development methodology, TTT methodology, and kind of a things, which we'll be speaking down the line. So these are some things that kind of the DevOps mentality will be kind of putting forward for any team to succeed. So basically let's understand why are all we here. So just to understand how much of testing do we already do, and what other ways can we actually test an application, and how can we enhance the quality and deliverability of the product as soon as possible into the market with the best quality. So the very basic reason that we are all here again for this particular session is to understand, or to shine a different light on the testing techniques, which is like to understand a variety of testing techniques for automating your entire system from the development phase till the deployment phase, and trying to test different aspects, not just from the code perspective, but also from the operations perspective. What can be tested, and how much can you be involved into the operations part as well. So that is something that we are actually kind of trying to understand from this particular session. And This is one thing that I've recently found, wherein this Snoopy cat is like, it tries to understand the code and it says there are 99 little bugs, and it tries to find one, and there are 127 more bugs. So it's kind of kind of saying that you try to find one bug and you try to fix it, and then there are n number of more bugs that are introduced into the system. It may not always be the case that all the bugs are like very small bugs, or minor bugs, or the severities and priorities are very low. There may be some issues wherein the patching may also cause you quite a big kind of blocker bugs and kind of things coming into the code. So the bottom line is like, you should always be testing the code as much as possible for regression, for functionality, for the latest functionality that is being introduced, for the performance, for the security and all these kind of things. So doing all of these things manually and kind of doing them in a waterfall model is not something that can be kind of a reality, because in the reality, you always need to kind of focus on the deliverability and the quality of the product, and this should be done within a particular timeline, right? So when you say timelines, if you are into the service group, or even if you are into the product group kind of things, you always need to understand that there is competition in the market, and in order to perform your best from the product perspective, you should always be delivering your product at the earliest with the best quality, right? So that is when this methodology of agile and DevOps has evolved. And agile basically states that instead of waiting for different teams to kind of deliver the responsibility to you, start working with them, right? So that is like start to build the test cases, start to build the test suits from the beginning of the development phase itself, wherein you'll be able to give the test cases to different development teams, and they'll be able to simultaneously test the things, and you understand what is the quality of the product being built, right? So with that particular DevOps mentality, agile DevOps mentality, right? The particular automation aspect has come in, wherein when you say we have to automate something, you have to understand what exactly is that particular tool being built around. You have to understand the dependencies of different teams, different tools, and different use cases or the test scenarios, and then you have to build an automation suite, right? So slowly we'll get down how are we building that particular test suite in the DevOps perspective again, because you have to identify the dependencies and resolve the conflicts, or even understand how can you kind of build a nexus between different teams to work together, and then get the automation done from the start phase till the end phase, right? So here is a small example wherein you can see that there are different kind of phases that are involved in the DevOps life cycle. Here you can see that the development and operations are two different aspects, wherein one phase is completely dealing with the code, and the other one is completely dealing with your infrastructure. And the operations part, wherein you can see that the first phase is your planning, which basically says that the user stories and the interaction with the product management team is something that is quite happening here. So in this phase, you'll be drafting the user stories, you'll be kind of putting down them into different tasks and all of this. And can we kind of proceed that into the next phase is already something that we have to do here. So what is testing here means? Testing here basically means that whether the user story is aligning to the functionality of the existing product, and if there are any changes in the functionality, or even if there are any upgrades and kind of things that are being planned at this particular phase, you have to understand the dependencies of the existing application and write down those things and kind of put them in your test cases. Like say for example, one of the one of the use cases maybe, or a user story maybe, like upgrading the SQL version to the latest version, or upgrading a particular Apache server or any such kind of a server's version to the latest version. And you'll have to understand what are all the kind of the different causes that may, different effects that it may be causing on the production environment, because the existing version of the database or the server in the production environment may be different. And when the version has been upgraded or any patching has been applied, if there are any issues that are being caught up, testing team will be involved in that. So why not plan for it from the beginning, right? And the second one is your branching phase and your coding phase and all of these things, wherein you will be involved in this kind of a test-driven development methodology, and you'll be kind of starting to understand the process of extreme programming, the model, which is also a part of agile development process, wherein they say that whenever the testing team gets involved, all right, they will start to ask questions in the code and starting to do work with a very minimal code, right? So if there is a new functionality that is required to be developed, right, it starts with a very basic code or code snippet that actually addresses the problem, and then it's slowly kind of gets down to the product, the proper codes alignment, or the complete code only after the initial functionality of the requirement is addressed. Such kind of a thing is part of the extreme programming, and the tester's role there is to start asking questions or to start building the test cases from the very beginning of the coding phase. And then after such kind of a code is developed, they would be putting that into a merging phase wherein different kind of modules of the code that is planned for that particular release, or a minor release or a major release, and all these kind of things would be coming in, and they'd be merging into one particular branch or into a particular code base. At that time, when the code was working individually, when it is actually merged, it may cause some conflicts, it may cause some issues, and then you have to test there also, right? So testing is involved in every phase of the development part, which is already known for all of us. The next thing is something that you can see on the operations side, wherein we have the release, deploy, operate, and monitor phases, right? So what does a tester needs to do there? Let's see what are all the different things that a tester can do. You can test everywhere in the product's life cycle, starting from the planning phase till the monitoring phase, which is again an infinite loop, depending upon the number of releases, the number of upgrades, the number of patches that you're planning to do. All of these things should be going through this particular process of planning till monitoring phase, wherein testing team will be involved everywhere. Now, on the operations side, as I said, we have the release phase, deploy, operate, and monitor phases, wherein the tester would be, kind of involved in the release phase, of course, because you'll be doing your sandbox, you'll be doing your pre-production testing, you'll be doing your sanity and UAT and all these kind of things on the release environment, or the pre-production and the sandbox kind of an environments, wherein your involvement is definitely required in terms of the features, the functionality, security, and the performance of the new features that are being released into the product. Now, what do you do in the deploy phase? As a tester, you will also be able to test, right? It is not a culture in every organization, but definitely some of the organizations are now taking up the testing teams and involving them into the deploy phase, wherein the deployment scripts, right? The scripts can be kind of built in Python, Shell, or any such kind of a deployment scripts and kind of things. But the testers will be able to see whether the functionality that is required to be available with a particular deployment script, is that available or not. You may or may not be writing the deployment scripts by yourselves, but you can still see whether that is working fine and give an immediate feedback to the teams that are working on that particular scripts, which are usually systems administration or the DevOps teams by themselves, right? So you can continuously work with them and kind of start testing their scripts along with them, and kind of increase that rapport, or kind of the communication between different teams, so that you understand what is actually happening and how much of your involvement can be required and how much can you automate. And then we have this operations phase, wherein you'll be having the servers upgrades and kind of things. That's what I was saying at the initial phase of the planning itself. If at all there is a database upgrade, say for example, okay, and it is actually kind of increasing more caching, or it is actually increasing the table size or something like that, and it may also be kind of increasing your security, right? So how much can a tester be involved there is again like before actually it is going into the production environment, right? The developers will of course be having the latest version of the database on their locals and test that before actually delivering the code till the release environment or building environment. In that case, the testers can also have a similar environment and start testing on the database with different queries or different patterns of the queries. How much of the data is it able to cache? How long is the caching maintained? If there is any requirement for the performance to be improved that way, all these things can be resolved at the very beginning of the code being delivered, before actually kind of waiting to test it until the operations fair, or after the deployment of the code. And then we have the monitoring phase, wherein whatever is deployed into the environment is required to work for a long time, right? So if there is a code that is deployed into the production environment, and just after 10 hours or 12 hours of the code running, if it is doing a lot of memory consumption, and you're not able to use the system any further, such kind of things can also be tested before actually delivering that all the way to your production environment. So these kind of monitoring, alerting, and kind of things are very much testable, and the DevOps teams currently do that. The testing team can also be involved into such kind of things to at least understand at what level are you able to see the alerts, because after the system is kind of totally not accessible, receiving an alert is actually pulling you off your SLAs, which is not the right way, right? So the testing teams can also be involved in understanding how the alerts are being set, and if there is any kind of feedback that the development team can also give to the operations teams or the DevOps teams, it is very much helpful, and it gives a very streamlined flow of the code from the planning phase till the monitoring phase of an individual applications. Here are the different phases. That is what we have just discussed in the DevOps infinite loop, wherein you have the development, operations, and the in that loop we could only see that the development and operations are kind of highlighted into different circles, and there are different phases involved. But here you can actually see how much is the importance of the testing team. We have said that testing is involved in everywhere, right? But what is the particular functionality, or the particular use case of the testing teams, or the very much important involvement of the testing teams in this entire process of software development lifecycle, right? So to start with, development teams, we have seen that code is actually being organized into different branches, and slowly they'll be writing their scripts in the test-driven development methodology, or the extreme programming methodology. These are parts of the agile development methods right now, and slowly we can see that the code is being built. It is created with different versions. We can see that each version is actually being tagged into different releases and these kind of things. We can also see that script building, which is basically like when they are writing their code, they may be kind of optimizing their code, or kind of reusing as much code as possible, kind of a thing. So Sonar Cube kind of tools are something that can be used in this particular phase, wherein you can see that individual code or component individual code component performance can be analyzed, and how much of the code has been reused, and how much of the quality code is being delivered is something that can be analyzed in this phase. The third one is dependency map, wherein, as I just said, if there are different databases, different other things that are actually required to be delivered, whether the latest versions of the plugins required for those dependent databases, or any such kind of things are actually being put into the code or not. Because if you have upgraded the database, but you're not supporting the latest version of the plugin that is required to connect to the database through your code, if that is not available, of course, that is not going to work. So such kind of things are some things that can be kind of put in mind, and the development team can start working towards that. Component deployment and system deployment are something that the development team as well as the operations teams can be kind of resolving at the very beginning of their time, wherein they have these tools nowadays available, like the containers, Docker or Rocket kind of containers, that actually help the developers start working towards their programming phase right from the beginning, and kind of building an environment rather than waiting for the systems teams to deploy them individual servers, and kind of wait for them to kind of give them an environment for their code to be tested. So these kind of things are something that the development teams are getting involved into. Now the QA team, the quality assurance team, which is very important, or the testing teams that are also involved with the quality assurance are very much important in this particular life cycle of software development life cycle, wherein the testing teams are very much closely working with the development teams and starting to work on building the test cases, test suits, starting to work on the automation, and they'll be doing different performance analysis and benchmarking, not in just terms of the functionality, but also in terms of security, performance, and other kind of things as well. And then you have your operations teams, wherein they may be doing some patching, or they may be doing some environment migrations. They may be doing some configuration management, and kind of configuring the security and kind of things in terms of the firewalls, or in terms of Viatas, different other methods in which there may be a vulnerability into the application, and they'll try to secure things as much as possible that way as well. And then operations is earlier, before the agile methodology, or before the DevOps methodology, the operations teams were doing their upgrades, and they were doing a rollback plan and all. Now, after having the DevOps methodology, there is always this mentality of doing the rolling upgrade, which is like, instead of keeping the system down for at least one moment, they are trying to upgrade as much as possible without the downtime or minimal downtime, so that there is always a high availability of the application, and there are no breach of the SLAs or the service level agreements that are made with different customers. So you can see that there are different arrows that are made between all these three different spheres of the SDLC, which are like how much of an automation can be involved in all of these three different phases. So automated build and deployment, automated testing, and automated provisioning. This is basically called the CICD, which is continuous integration and continuous delivery and deployment. Okay, so this is something that actually pushes up the concept of CICD, and DevOps is entirely built around this particular aspect of the CICD, which is continuous integration, continuous delivery, and deployment. Now, the involvement of the testing team in all of these phases, and kind of also getting into the CI/CD part, is something that we have to definitely analyze on, and focus more towards the test ops instead of just the DevOps, or just the regular way of working of the testing teams, which is just automating the code that comes in and being limited just to the testing side, the code side of the entire SDLC lifecycle. So that is something that we are trying to kind of analyze, or throw some light on for the test ops to be evolved, and eventually get into the process of SDLC and expedite the quality code being delivered to the production environment. So as I said, everything is required to be tested from the very beginning rather than waiting to the end. So this is something called the ShiftLip approach, which is when you are starting to do things from the beginning, that is shifting left in the software development life cycle, right? So instead of waiting for the product to be going into the production and starting to do any kind of a testing, there is not an ideal approach, right? So no one is actually waiting for the code to be deployed into production and then testing it, right? So what are we doing right now? We are already doing the coding and kind of starting to test the code with unit test cases, or JUnit kind of a tools for doing the unit level of testing in the code and all these things. So start to kind of do testing from the very beginning, which is from the requirement analysis phase, wherein you understand the user story, ask as many questions as possible, give a product kind of roadmap, understand the product roadmap, and then start to kind of align your test suits and test cases in that particular direction, right? So that is basically shift-left approach, which is like you're doing the testing from the very beginning, and kind of taking it through different phases so that the quality is always enhanced at each individual phase, rather than waiting for someone to actually tell you something is breaking at a particular level after it has been going into the production kind of an environments, right? So these are all the advantages that you can see at the bottom, which is like you have the competitive advantage because you always have automation and kind of things in place, and you do not have to manually manually test every time. Manual testing is required definitely in terms of different, if it is a mobile application, say for example, right? And it has to do with something with the camera or kind of things. Of course, there are automated tools, but you still have to understand the device level, kind of functionalities and kind of things to completely ensure it is quality tested, right? So these kind of things are something in terms of automation, you can say. But for a regular web application or for the API automation and kind of things, you always can build automation suites around, right? And at least address the generic use cases rather than going into the intrinsics of doing different testing methodologies and trying to automate them, right? Automation is good, but too much automation may also lead to kind of a confusion, which is not good in some of the use cases. So with the shift-left approach, you can see that there is a competitive advantage because you are able to deliver the quality code to the production environments faster. And then you also have a higher quality because you are able to test it at individual level of environments or different phases of the software development lifecycle, and you're always ensuring that the quality is good. And then you have the higher efficiency because you're testing for the code level aspects as well here, which is what I was just saying some time ago. With the test-driven development methodology, you are able to sit with your developer also and try to understand if there are any kind of concerns. Though testing teams may not always be involved in the TTT development methodology, which is like the developers, right? They do the pair programming, and in the pair programming, they may be doing a test-driven development methodology wherein they'll be writing a piece of code and start to test it to fail, right? If the code is failing, they'll be kind of failing for addressing a particular scenario of the functionality or the use case. Then they'll be building around the right kind of questions around it, and then start to build it the right way, right? So that is the importance of questioning or testing your code from the very beginning, which is why TDD or the test-driven development methodology has been very much famously adopted in some of the companies, right? And then you have the cost reduction as well in this shift-left approach, which is basically like, because you're not doing any breach of SLAs, or you're not doing the testing at the end of the life cycle and kind of things, right? So this actually reduces your costs as well, because you're also trying to automate things and not wait for anyone to kind of deliver something to you and then only you're able to test things. No, you are able to do things parallelly with the development team. You are able to do things parallelly, test things parallelly with your operations, migrations and all. And then you are able to see that there is an immediate quality enhancement and a fast or the speed delivery to the production environments. And then this is something which basically I was explaining all this time. This is all you can read. If you have a minute, you can read, or I can read out for you, which is like, shift-left approach is a QA practice being implemented in the high-performance, kind of agile DevOps teams that provide an effective means of performance to the teams in parallel and during and in parallel to the software development activities. Software development, test, and operations work together to plan, manage, and execute automated and continuous testing to accelerate feedback to the developers. The rate of the feedback is determined by an organization's desired velocity, which is like the release frequencies or kind of things. And then you also have the technologies used to automate processes and visualize components. QA testing teams perform as part of the development process or as service running in business-driven development or development-driven development is a parallel to development activities. Shifting left accelerates feedback to developers and improves the quality of the code delivered to the QA. Shift left is an essential capability for agile DevOps teams and IT operations teams. Right. So instead of kind of going through such kind of long text slides, I just wanted to kind of explain everything rather than just reading through this slide. That is why I kept all my slide text to be minimal text and as much images and kind of things. Right. Here you are seeing that there is a screwdriver that is hitting in the hammer into a particular piece of wood. So here we are testing for the quality. And I think most of us know the difference between quality and testing. Quality is actually something that understands the alignment of the product the functionality and the kind of services that are being offered by that particular product, are they actually aligning to the business needs, right? So that is something that we are seeing for this particular thing, right? So here we are saying, is this a good quality product? When we say quality product, the quality product is not just kind of doing the purpose by itself. It is also for kind of setting up the entire use case for the business to work towards it, the functionality and the requirements that the user actually has, right? So that is what quality is. Testing is like whether it is working fine, whether it is actually kind of addressing the concern or not, is basically testing. Now here we are able to see that a screwdriver is hitting a hammer, hitting a nail into the piece of wood, and that is just doing the job, right? So, but the thing here is you're able to see the usability concerns, right? Because the user handling the screwdriver at the sharpened end and trying to hit the nail may be kind of causing him some issues, right? It may be kind of damaging his hand or kind of a thing. So usability, the functionality, security, and performance of the product will all come into defining the quality of the product, right? So these are all different aspects, because we can test for functionality, we can test for security, we can test for performance, and we can test for the usability. But all of these put together will only kind of ensure the quality of the product, right? And then here we can see that we have already seen what is ShiftLip approach, but where all can the testing team be kind of involved in this particular thing? What are all the different phases that we'll be going through as a testing team into the ShiftLip approach is something that we can see here. That is prevention, then detection, involving testers in every stage, test continuously, test early, test every time, and test everything, right? So with this particular thing, you can always understand that within the entire functionality of your code, within the entire kind of a development process, at every phase, the testing teams can be involved. They can be doing as much contribution as possible and try to automate, try to question, try to kind of break things as much as possible, because that is something that we have to do and we are all being paid for, right? So quality and testing is something that you have to take as a responsibility as at every phase of the product, not just into the coding side, but also try to be involved into the operations side, because the delay from the operations will also delay your entire delivery process to the production, right? To start to get involved with the operations teams and try to kind of test their deployment scripts, or understand how actually a particular script is working, because I think most of the testers are not included in the release cycle. So you should also be kind of involved into the release management cycle. Sorry, not the release cycle, it is towards the release management cycle, which basically is to deal with the operations part or the infrastructure part, and eventually kind of start working towards the complete automation from the development phase till the operations phase as much as possible. Now here we can see what are all the different kind of testing things, or which is business facing, which is product facing. So as I just said, quality defines are we building the product right, and the technology also defines that are the products that are building, are we building the right product or the product right? So are we building the right product basically addresses the user's concerns, their requirements and kind of a things. And then are we building the product right, which is the technology facing side, which basically says that whether a particular test case that is given for that code, is that working fine or not? But we are not seeing the end goal from the technology phase sometimes, right? So we have to understand how much of the nexus should be existing between both of these things. And of course, it should be 100%, because whatever you build should actually address the requirements of your customer, right? So building a function like a plus b is equal to, or 2 plus 2 equal to 4 is something that you say, yes, technically this is right. Now, but your customer actually wants 10. So 2 plus 2 doesn't work for him. So you should build either different combinations of, kind of 5 plus 5, 2 plus 8, or any such kind of thing. But yeah, you should always understand the end goal, which is the business requirement or the customer's requirement, and then also kind of plan your or architect your technology around that, right? So when we say we are talking in terms of the DevOps and kind of the methodology or the mindset that we want to put into the testing here is basically like to understand the customer's perspective, try to automate as many things as possible, right? And put the quality into their hands, quality product into their hands, which basically is you are trying to build everything and also making sure that built things are not actually something that you are kind of wasting your time with, but you are actually making quite a big progress towards the business functionality and requirements. Now, so here you can see which are all the business facing things and the technology facing things. The business facing ones are the functional story and the prototyping, and they are also supporting the team in terms of kind of building the different tools and aspects of it. And then you have the exploratory and usability testing, which is basically from the critic perspective, or you have to analyze the usability of the application, which is something that I've just said some time ago. And then you have the performance and security and the load testing kind of a things, understanding how much of the critical aspects are you able to kind of cover with your application, such as some things. Those are some things that you have to cover from the critic perspective. And all of these, of course, would be involving the technology phase, right? So, and you have the unit and component testing, which is from the your developer perspective, or a very good code tester perspective, who does an individual component testing and the unit level testing and try to involve as much use cases at that phase itself, and then progress into higher levels of things, right? Of automation or higher levels of different things. So we have seen all of this until now. Of course, all of these people who are attending today's session are quite a good QA and testing people. So let's see, we definitely have a very good understanding of the user stories and requirements, how are they built, and how much test cases and test tools should we be building around those user stories and the functionality requirements and all. And then how do we actually manage the source code, and whether it is from the development perspective or any automation suites that we are actually building, and where are we keeping those codes, how many versions are we actually building for each of those automation scripts that we are building around. Are we using the the source control tool or the source code management tool the right way from the tester's perspective as well. And then we have the product management tools, wherein they have a dashboard or different tasks that are actually being created for individual user stories, and individual bugs that are also being kind of observed in the production or even in the current testing phases will be put on the product management dashboard as a part of the user story or different aspects that are observed there. And then the environments, which are very much required for you to test, also for your developers to kind of do their regular deployments and trying to kind of analyze whether they are able to address the functionality of the code that is required and all. So we have different environments, which is development, testing, pre-production, your sandbox, your production, and these kind of environments. And you can also kind of put your testing cases in those environments as well. And we have been talking quite a lot about these different methods and tools that are required for our kind of testing execution and the automation phases. But all of these things would work with your different sets of testing tools. So what are these tools? How should I be choosing those tools for my automation purposes? How much of a quality am I building around? Are these tools that I'm choosing, are they actually addressing the concerns that I have? Will I be able to reduce my manual efforts and kind of put things into the testing suites as much as possible? These are some things that you have to analyze, and let's understand how are we doing that, right? So here you can just see a very basic kind of understanding wherein what is false positive and what is false negative, right? So false positive is basically like you don't have an issue basically, but then it is still being reported to you, right? And then false negative is you actually have something, an issue or something, but then that is not being kind of notified to you as an issue, right? So choosing the right automation tool, or kind of to identify the right set of tools that fit into your use case also should be should be addressing this very basic point of identifying what is false positive and what is false negative, right? So only after that you will be able to see whether that particular tool actually fits into your entire use case. Because if the tool is giving the very basic details to wrongly, or kind of addressing your concerns very wrongly, in that case that tool is not good for you, not at all, right? Now let us understand how do we actually build or kind of choose such kind of a tool. So the tools, such kind of a tools can actually be built around sorry. All right. So these kind of tools are basically identified and built around using your decision tables, or you have to kind of list down what are all the requirements that you have. So just take an example from the testing perspective as well, wherein you build a decision table and you see how many test cases will you actually have around that particular use case, right? So here it's a simple kind of decision table which actually validates your kind of logging into a particular application, which says with the valid user ID and valid password, how many use cases can I build, right? So here you can see from the testing table that you have like 5 different test scenarios, and then you have so and so number of test cases. Now at each time, right, when there is a positive, which is like a correct user ID and a correct password, you're able to get in, right? With a correct user ID but the wrong password, you are not able to get into the application. And with the false user ID and correct password, and with the false user ID and false password, you're not able to get into that application. So these are some things that you'll have to understand for testing your application. These are the minimum kind of use cases that you're going to build, and that is how you're making your decision table. Now say for example there are n such kind of conditions that you want to check, because this is just 2 conditions that you're checking and you have your actions that are being generated, right? So the number of conditions in that case would be 2 power n or 2 power x number of tests, depending upon the number of kind of conditions that you define. So for x conditions, you have 2 power x test cases, right? So similarly, could we reduce the number of test cases, which is basically like, say for example, you have 100 conditions. 2 power of 100 is quite a big number, right? So can you reduce the number of such tests? It is basically done by a basic methodology or an approach called going to Moscow, which is basically not that Russian Moscow, but you have the must, should, could, and would kind of things that you have to analyze when you are actually writing down your conditions, and try to address these things at least in order to kind of fit your tool, fit your test cases towards the purpose that is required for it, right? So say for example the tool must automate my requirements or the test cases written in Java. So what are all the supported tools for that? Try to kind of get down them, right? The tool should be having a plugin kind of an architecture. So what kind of tools are supported for that? Go for that, right? And then the tool could be doing something which is related to security analysis or something like that. That can be your third filter. And then you have your would, which is basically like it would be generating reports for me without actually kind of me doing some plugins and kind of things, which is another filter. So these are some examples that I'm just stating, but you can just kind of completely take them into a particular checklist. Try to filter your conditions according to these kind of must, should, could, and would kind of things, and try to identify the right set of tools that are required for your automation suite. Here you can see what are all the challenges as a team. Not just the development team, the operations teams, the testing teams, everybody has these challenges, which are basically the systems and the technologies, the code changes or the number of deployments that happen, the number of scripting languages that you have to support, the non-functional testing that is required to be done on them, and then the complex reporting structures. Some of them may not even have the reporting structures properly. And then you have the framework complexity, which is like if you do not understand the architecture of your application and what kind of a framework it is actually being built upon, you may end up testing it the wrong way or not able to identify all the issues that may be kind of getting in the way of your application, right? So these are some things that you will always have to kind of analyze through and kind of try to address these concerns and build your technology tools or the automation tools around addressing these concerns as much as possible. And then here you can see, as a testing engineer, you will definitely go through all these kind of things, right? You will be seeing Selenium, you'll be seeing Maven, you'll be seeing JMeter, TestNG. If you're doing some security, you may be doing OWASP, ZAP kind of a thing, and then APM for your mobile security, mobile automation. And then from the browser perspective, you may be supporting different versions of the browser and kind of things, and each of these things will be requiring infrastructure for you, which is basically like you may have to have a testing environment set up, and all of these things should be present in your testing environment. So in order to have all of these things in place, you'll always have to have the infrastructure, which is having individual servers that are deployed with the right set of databases, with the right set of plugins that are required for it, with the right set of tools like Selenium, Maven, and other things that are installed on it, and all these things, right? And for the CI/CD purpose, which is basically Jenkins or GitLab or any such kind of a tools, you may be waiting for another server to be deployed and wait, okay, let the operations team come back to me stating that a particular server has been deployed, which is basically your wait for time and also cost improving or actually it is impacting the cost of the team as well, because they are actually required to deploy a new server just for this purpose. Instead, if you have this possibility of testing things within your local environment itself, rather than putting things into a public, a private server and putting more costs on that, you can actually spin up all these things on your local itself. So let's see how can we do that, right? So here we can see how much of the operations, as I said, how much of the operations can you actually test from your local, how much can you be involved is something that here we can be, kind of analyzing. Operations in testing as a concept revolves around ensuring product teams have access to any required test infrastructure, platforms, and frameworks they require without needing large amounts of the time-consuming configuration before commencing tests. Any benefit from use of the CI system will be lost if the QA process takes days to complete due to environmental setup and tear down on the part of the QA person on a team. We will require deep knowledge for this the architectural knowledge, coding knowledge, software engineering knowledge. You may gain all of this from the ISTQB, but you may not be, actually doing all of this from the syllabus that is given in ISTQB, because it is not something that is addressing all the concerns. It is generic, but you still have to see things as much as possible from your business perspective and your day-to-day improvement at work as well. Because if you do manual testing every day, what difference are you making to your own career, or what learnings are you doing by yourself? Right? It's not just the business. You also have to understand, if you want to retain into this fields of quality and the continuous improvement and delivery and kind of things, get involved into the operations part as well, and try to learn as much as possible in terms of the automating tools, and try to understand the requirements and dependencies of your applications into different versions that are required, or as much support that you can give to different teams as a QA person or the testing person. So here you can see what are all the dependencies again that we are actually talking about, which is like the tools that are required to be developed or used. Many of them can be open source, some of them can be in-house built, some of them can be cloud deployed if you're using AWS or GCP kind of cloud platforms, and you also have some of the commercial testing tools and kind of things. So identifying the testing tools from the decision table that we have just talked about some time ago is something that you have to do. And then the testing environment, you have to build the testing environment locally as much as possible, instead of waiting for your operations teams to kind of build something for you, rather than you trying to do them with Docker or any such kind of a thing, which basically is something that we are speaking about here in the terms of containers. containers, public clouds, IoT, and private clouds or on-prem environments are some things that you can build your test environments on, and start building containers, which is Docker containers or RKT or the Rocket kind of containers are something that you can start using, so that you always have your testing environment ready rather than waiting for your operations teams to provision something for you. And then you also have your RESTful services, which can be tested, and you always have to ensure that these are developed and deployed for you to keep testing on. So Swagger is one such tool that actually kind of provides you the REST API documentation, and you can start your testing automation of the APIs in terms of using them with the right request payload and kind of things. And Swagger UI is something that you can be using as a tool for provisioning that environment for you. And from the backend, there may be different kind of coding patterns which can be in Python, Ruby, Java, or .NET. And being aligned to such kind of things from the development perspective is something very important. And start building your environments from the containers, so that all these environments, because Docker is nowadays supporting n number of environments and coding languages, so you always have a flexibility of spinning up an environment in seconds rather than waiting for any particular team to deliver you something. Okay. And this basically shows up different tools that fit into the DevOps perspective, the continuous integration, deployment, and delivery model. Here are quite a lot of things that you are seeing from the planning phase till the monitoring or the maintenance phase. So planning and coding actually kind of can be going into planning can be going into your Confluence and Jira kind of a things, wherein you always have your user stories, bug reports, and quite such things that are put into it. And your coding, which basically is something like your Git or SVN or your TFS, Team Foundation Server kind of a things for managing your source code. Such kind of things are something that you have to have, because you have to manage different versions of the code being delivered for individual releases, and doing the right set of branching and coding the right set of branching and tagging is very, very important in terms of delivering the right code to the production environments. And then you're building using Maven, your Ant, SBT, or any such kind of a tools, and then you're creating a package. And testing that package is very important once built. So Selenium, JUnit, or APM kind of a things are some things that you use for your testing perspective of the code. You can test every other aspect, as I just said, using different tools and different approaches, and kind of build this attitude of working with the teams closely and understand their dependencies. Try to test and question as much as possible, and then create a good nexus between different teams, and kind of speed up the process of delivery of the product to the production environments as much as possible. And then we have the release phase here after the testing phase, which is basically something that I've just said, which is CICD, continuous integration and continuous delivery and deployment, which can be done by different tools like Jenkins, GitLab, or CodeShip kind of a things. And then you have the deployment. Deployment is done through your deployment environment size, either Docker containers or the AWS EC2 instances or AWS EKS and kind of a things. Nowadays, Kubernetes is also something that has evolved as a practice of highly scalable environments. And you can also try to kind of test your hand, test your skills in such kind of an environment, but start learning things with the Docker kind of tools, which is very important. And then you have your operations phase, which, as I just said, which is Chef, Ansible, and Kubernetes kind of things, wherein you'll be able to understand how the code is being deployed to different environments. It can also be done by a simple shell script, but these tools like Chef and Ansible are some tools which are very much kind of adopted into the DevOps environments, wherein they want to manage thousands of servers, and for a higher efficiency and better configuration management, and creating an immutable infrastructure is something that these kind of tools can do. So we always have to kind of acquire such kind of tools into the environments and try to test as much as possible with such tools as well before actually putting them into the production. And then the monitor, as I just said, Nagios, Splunk, Datadog. We also have New Relic kind of tools, which are some of these are open source, some of them are again your licensed tools. But what you can do is you can be testing these things, whether they are correctly working fine, or when there is actually a system level alert, are you getting that alert or not? These are kind of things that you can do some testing from the DevOps mindset or the test ops perspective. So as I said, Docker is something that you can use for building your application or deploying your application locally, and start testing it without actually waiting for an entire environment to be built. And this is something that you're actually seeing as a Docker, which basically is an abstraction on top of your VM or your local environment. So you always have the VMs. We already have the VMs, which are a higher level of abstraction, and Docker is something that leverages the underlying host OS and the server, and then it provides you with different binaries that are required for an operating system to run. It is not required, or it is not necessary that the container operating system should be the same as the host operating system. Like on top of a Windows operating system, you can run a Linux container, or you can run a CentOS container, or you can run a Ubuntu container. So these kind of facilities are something that Docker provides, and it is a lightweight environment provisioning tool. And it is always easy to port and create as many applications as possible with the Docker containers. So start acquiring this methodology of doing your own applications on local, and start building things and doing the testing from the local. So here you can see how it actually works. Code is locally done on a feature branch, and then the feature branch, if it tests all the if it passes all the tests, which are unit tests and different other tests that are required to be done on it, you'll be doing a manual merge, and you'll be doing a pull request. Basically, after the pull request is done, the automated tests are run on it on the Docker container, which actually gives you the required set of packages and operating system backing and everything. And then you have the if all the tests are passed, then that particular branch is merged into master or the production branch. And once merged, all the tests are run on it again, which is on the set of automated test cases that are required to be executed for the regression as well as for the feature testing. And all of those, if they are passed, then the Docker image is finalized. It is tagged, and then it is then put into the production environment through your CICD, which is the continuous integration and deployment tool, which can be Jenkins or GitLab or any such kind of tools. So here you can see the entire workflow, which is from the source code management till the deployment environment. So here you can see that initially the code is being built in the SCM. It is being built with Maven or any such kind of a tool. And then a verification happens on it using your testing automation, or it also uses SonarQube kind of an environment. SonarQube kind of a tools in order to do the code quality check. And then the artifacts, which are basically the jar files or any such kind of a things, are built. And slowly they are taken into your automated regression. And after the regression testing is done, you may also have to do some manual testing, as I said, depending upon the type of your application. If it is something related to mobile or something related to any particular specifics of the application, in that case, doing a manual check is also important. Then at that phase, you will be able to understand if it is fit for production or not. There you go and go or no go, and that is when you actually understand the entire requirement of automating things as much as possible from the start till the end of the software development life cycle. So here you can see what are all the different phases again, which is kind of different tests that are involved in this. So from the development phase, you have the unit test cases. From the build phase, you have the unit test cases, which are written on your packages, and you'll be doing the basic package evaluation and unit level testing is done on that, which can be in Maven, Ant, or any such kind of a thing. And then you have your test suite, which actually does the component tests, integration tests, and performance tests. And then you have your staging environment wherein you will be doing your UAT, user acceptance tests, and the performance tests. And on the production environment, you may be doing the system testing and the performance testing depending upon the type of the environment that is required to be done and the choice of the tools that you have taken. Now here, the important thing that you can see here is on the top, you can see the CICD tool that is being chosen, which can either be Jenkins or GitLab, and how it is able to efficiently manage all of these kind of things. So even SCM can be put into that, because your source code management is something that the CICD tools can do nowadays. GitLab is one such example, which is an inbuilt CICD tool, and that is something that we are using at our organization as well. So the importance of the CICD, which is basically the base of the DevOps mindset, is something which is highlighted in this one, and it understands how much of the testing is required to be done at individual phases, and how can we expedite the process of development or deployment of the quality code into all of these environments. So this is the DevOps infinite loop again. So it just shows up how many different tools are being involved at each individual phase. And as I said, the core of DevOps or TestOps or any such kind of XOps is basically automation. How much ever you can automate, how much ever integrations that you can do with an existing set of use cases that you have, and trying to enhance your application and communication between different teams for the smooth flow of your code from the development phase till the operations is something very important. And here you can see Slack, Docker, you can see GitLab, and all these kind of things which are very much required. And in order to have a smooth flow of your information and code flow from the coding phase till the operations is done through many of these tools. And this is just one set of it, right? And then here, the main thing again, the final a part here is to understand the dependency of the testing approach with the DevOps mindset is how much things are you able to put things into continuous integration and continuous deployment. How much of your automation suites can go into that? How much can you actually be involved with the development teams and the operations teams to understand the nuances of introducing a new feature or just a database upgrade or a server upgrade? And what are all the different aspects that you have to test? Say, for example, there is a new patch that is available for Tomcat, and that patch actually does some security level patching. If you do not understand what exactly is it patching, you'll not be able to test it for it, right? So what security feature is it patching? Say, for example, it does some ciphers encryption and kind of a thing. So if you do not understand the basics of ciphers, you may not be able to test it the right way. So you should be having the right level of understanding of these things. And learning is, of course, one of the essential components of any particular team, right? So we will be learning quite a lot in terms of our product, in terms of the technology, as well as implementing that into different use cases is something that we learn and we adopt to. And that is how we will be doing our continuous testing approach from the DevOps perspective, which is like automating things, learning new things, and leveraging the existing functionality and include teams and breaking the silos in each individual process and expedite the process of delivery of the code from the development till the production environment. So there is a small demo. I'll not take much of your time, which basically is an example of the code that I have. And it shows up how automation is done, how much of an integration of automation tests can we be doing in terms of the CI/CD tools or the continuous integration and deployment tools. So this is a GitLab environment that I've chosen, which is a very chosen tool nowadays for the continuous integration and continuous deployment. And here it shows a simple use case wherein it is testing the security of the code that is being delivered. And it does a simple evaluation. When I just run the pipeline here, you can see there are some pipelines. So these pipelines are some things that are being executed against the code, and they show up different functionalities that are being tested for. So I already have the code in place. I have a file called GitLab CI
Hi,
file.
Mahesh this size. Probably your other application is not shared. We can only see the PPT.
Oh, sorry, I'm presenting it now. Yeah, is this visible now?
Yeah, you may want to restart from where you started, like some 30 seconds back.
All right. So the screen is now being shown, right?
Yeah.
All right. So you can see that the code is now built. So this is a basic Java application, and it is actually building Gradle and Maven packages into it. And it runs a Gradle build, and we can see that all of these things are being downloaded into a Docker container. Here you can see it is being executed on a Docker runner, which is a Docker runner, Docker container. And I'm not waiting for my operations team to kind of prepare a server for me, and then I'm saying that okay, I'll deploy only onto that. I am running all of this on my local only, right? So I have a Docker container running on my local, and this is something that is being executed on that same Docker container. And here the build is done, and we have some phases, which is the testing phase, in which we have the regular application level testing, which is a very small suite that I've created for this one, which does the unit level testing. And then we have the SAST and DAST, which is static application security and dynamic application security testing. So these are some things that are directly integrated to the GitLab server. So GitLab provides this out of the box from the static application and dynamic application security perspectives. And what is the difference between static application security and dynamic application security? Static application security is like just going through the code which is available, and dynamic application security is if you give an endpoint of an application, different perspectives of the security testing are done on it, like XSS, like SQL injection, cross-site scripting, your user session cookie validation kind of things are different things that are done in the dynamic application security testing. So here you can see the dynamic application security is also done in one of the endpoints, and it goes through different kind of application that is deployed. HXCICD is something that I've actually deployed as an application, and it has done some evaluations on that. You can see cross-domain misconfiguration, CSP scanner, server leak information, HTTP parameter override. These are some kind of vulnerabilities that it sees, and it shows them to me as a warnings. Now here, I can also see the security dashboard. Oops, sorry. Oh God, looks like the demo gods are not with me. But anyway, so these are some kind of tools that you can see that you can be using for your continuous integration and deployment, wherein you can see that there are different phases of the testing that have been done, different types of testing that can be done, and all with a single dashboard or with a single tool. Okay, here you can see that there is a vulnerability that has been found, and it reports what kind of a vulnerability it is. It is a CRLF injection. Kind of a thing that has been identified. So these are some things that you can see in your CI/CD pipelines can be introduced, and trying to adopt to these kind of tools and putting your automation tools into place with the end-to-end continuous code quality and deployment is something very important. And as a QA team, you should also make sure that you always have the right set of mindset for automating things and choosing the right set of tools for making your quality better. So that's about introducing the DevOps concepts and the significance of the DevOps mindset into the QA. So I'm open for questions now. If you have any questions, kindly shoot them at me. Are there any questions? Hello, am I audible?
Yeah, Ravi, we can hear you. Let's just allow like a couple of minutes for people to
Sure.
post any questions if they have.
No problem.
We can start answering them.
All right. So about the DevOps mindset, once again, it's very much important for everyone to kind of understand how much it is required for adopting it, and automation is required, as I said, but do not try to over automate anything, because only after you start automating things you'll understand what is the importance of it, and how much of a time can you actually spend in terms of it. And it is very much requirement for being aligned to your business requirements and functionality as well. So try to plan your kind of a development cycle, the SDLC, or the software development life cycle, as much as possible in terms of aligning to the business functionality, and try to include automation as and when it is important, and in the areas where it is required to be, because there are some places you may not, or you cannot include automation into, but you still have to kind of understand the significance of it and put down the quality into it. All right, so that's a good question. From where do we want to start DevOps or DevOps? What are those few steps by they should be taking? Right. So the basic thing is like identifying the areas that you can automate, and try to understand the dependencies of different components that you're actually working on. Like, say, for example, as I said, you're working with your code, you're trying to push your code into a source code repository. Now you have to understand where are the source code things actually being managed from, and how when you are actually building your test suite, right? Are you waiting for a particular team? Don't wait for such kind of a thing. Start working towards creating local environments, which with the Docker kind of a things, right? Start learning these new technologies like Docker or Kubernetes kind of things, which will be making sure that you're ready to test your applications from the very first build, and you can create different environments. Instead of waiting for the operations teams to deploy a new database for you in your testing environment, you can have one version of the latest database on your local itself. You can have a current working version of the database image with the Docker image that you have built, and you can have one latest version of the database with a MySQL or whatever in the latest Docker image as well. So trying to work with these kind of new tools, which are part of the DevOps culture, as here that I've just shown, is something very important. So start analyzing the dependencies of your application, what are all going to be into the production kind of things, and start building applications on your local, at least start working from the smallest things, so that you will not end up doing testing at the final product, rather than you start building the quality into the system from the very beginning. So Docker, doing the configuration management, starting to analyze how a particular shell script works. These things are very important. I'm not saying that you have to turn into operations person, but having a knowledge of operations is also important for the QA people. That is why this new term called test ops is being evolved, and there are quite a lot of kind of talks that are going in, and there are many such kind of development activities that are taking place along with the test ops kind of a methodology nowadays, right? In specific, that's what I was actually thinking, that start working with the Docker kind of a tools, and build things as much as possible. DevOps is one of the highest culture that is being picked up in, I think, not just outside India, in India also, because in Bangalore and in Mumbai, I've seen quite a lot of startups, at least, kind of having this culture of DevOps. And even I was working as a DevOps. I started my career as a DevOps in India only. So India is one of the best places to, kind of start working as a DevOps. The startups and, the mid-level companies are embracing this culture of DevOps. So, which basically again means breaking the silos, right? You should not be waiting for someone to give you some responsibility or, kind of deliver something for you. Start working with different teams, start building your local environment, start trying to automate things. And, that is something which actually, kind of breaks the silos, starts to, kind of shift left things, from the beginning of the cycle rather than waiting until the end. So the culture is very much adopted in India also, and there are companies which are taking up this as their highest priority. Also, there is something that we can see is like not every company. There are some, quite a big companies which are not yet into this process of adoption, but they are started to doing it, which is basically like they're starting to, re-architect their applications so that they do not have the dependencies of waiting for individual teams or the waterfall model kind of a thing. So it depends upon the, as I said, it is also depending upon your release cycles. How much can you actually deliver? How much do you need to actually deliver? Because some product teams may not always require to deliver every 6 months or every 2 months. Depending upon that release frequency, you can also decide how much of the DevOps can you actually put in. Right. Switching to DevOps is not something that I'm advising for the QA people, because some people definitely have this, kind of attitude of testing things the right way and, kind of bringing the best quality. It's only, so it's not like changing profiles or, changing your profession. It's only like taking up a new methodology of testing, right? So that is why I was saying this term called test ops at the end, right? So when we say test ops, you still have the critical functionality to be tested by your testing teams only. Switching to a DevOps is not making sure that your quality is delivered. Test ops is something, or including the methodology of the DevOps into testing is something that makes sure that you are automating your process, that you are delivering the quality, that you are making sure your test cases are being passed, and all of these things are actually being centralized, and they are being done from the CICD, the continuous integration deployment tools, or something like that. So as I've just shown the GitLab example, wherein your code is actually being run through, and you're doing the security testing, you're doing the performance, you're doing the quality evaluation with a single tool, right? So you don't have to run through 100 different dashboards and analyze the quality, or kind of get the status of individual features, and kind of then condense all of them and say that this is qualified. So you have one dashboard, you can reduce the number of tools that are being put in, you can have as much automation as possible with a single tool. Try to plug in different other things into that tool and kind of leverage on that, rather than going for 100 different tools. Try to condense your requirements, try to make them into the perfect fit for your application to be automated, and try as much as possible into that. Switching profiles or changing professions is not a suggestion of this particular talk. It is only to embed the mindset of a particular profession into our current testing environment or the testing mindset, so that we always can also focus on improving the product's automation and quality simultaneously. The very big difference that I have observed during the transition from the testing phase to the operations or the DevOps phase is like, as I just said, I was doing quite a lot of manual and automation testing using, just my product related features only. It's like, okay, I'm only limited to what I'm given. but I was not exploring out of the box, right? So DevOps or switching into release management and DevOps is something that I've got very good advantage for myself, because I've learned quite a lot in terms of the architecture, how a system actually works, how the browser works, how the traffic manager works, how do you actually configure the security, right? And how the databases are required to work, how the caching works. And this actually gives you a very good understanding of an overall system's working, not just limiting you to the functionality to be tested and how much can you automate on that. So it's a very good exploratory opportunity in terms of the software, how it works, and how can you automate as many things as possible.
All right, so wonderful answer, Savi. I think that's pretty much what we have in the questions.
Thank you. Fine then, if we
Wonderful
have any more.
Thanks to you for taking your time and jotting down wonderful points and sharing it with the tribe.
Sure. All right. So thanks, team. Thanks to the Test Tribe team. It's a very good opportunity for me to share what I know, and hope you like it. And if you have any questions, you can reach out to me on my LinkedIn, and I'll be available for answering. Thanks a lot, team. Thanks, and have a great afternoon.
Thank you. It was a pleasure hosting you. Thank you. So I'm ending the live stream in 5 seconds from now.
Sure. Thank you. Thanks, guys.
Bye.